We have been working on solving systems of equations. We've done it two ways so far. One, we have graphed them. Okay, we graph both equations. And we find the point of intersection. Okay, and that point is the point that makes both those values of x and y. The x, y is the only combination that makes both true. Both equations true. Okay. It's a nice visual, okay? Its pro is that it's visual, okay? It gives you practice graphing, but you see what you're actually finding, okay? You actually can see what you're finding is actually that point where they intersect, which is on both lines, so it makes that equation true, okay? The con of this, the thing that's harder for it, is if the points are fractional. Then it's harder to get the exact point, okay? So if the two values, the x and y, are fractions, we can't read it off unless we use some program like Desmos where it will read it off for us, okay? But back in the day, they didn't have Desmos, so they had to learn how to do it with that. And you're not always going to graph equations on a graph and find their point of intersection, okay? Because you have to know how to use the graph, you need to know how to scale it, you need to know a lot of stuff to make sure it works, okay? So the next way we went into solving them was called substitution. This is what we covered yesterday. What we did is we found the value for a variable. We found the expression equal to one variable. Then we substituted it in for in the other equation, I should say, in the other equation. Oops, didn't write other. And solved for one variable. And then for the second variable, you put answer back in the expression. Okay, so example. I didn't draw an example of the graph, but I will give you an example here. We solved an equation like this. Okay, here we know what y is in both cases. Okay, so this was the first kind that was really easy to do. We could say, oh, y is 3x, y is also 3x minus 2. So we could then say, okay, let's make 3x equal to 2x minus 1. We substituted this in for y there. Okay, so we just substituted that expression into the second equation, got this, and I can solve this by minusing 2x. So x is equal to -1. So we got x is -1. Now we're going to go back up to this expression here again and put x in there. So y is going to equal 3 times -1. So y is equal to -3. Okay, now I know those two, so my point is -1, -3. If I graph those, that's the point where they would cross. Okay, so that's one of the ways. It's when basically they're both written in slope-intercept form, then it's very easy to substitute them and do the solution, because that was a very easy thing. Okay, so then the other kind that we solved was something like this. Y equals 3x plus 2, and then we have 2x plus y equals 10. Don't ask me what I'm going to get here, it's just making these up. Okay. So in this case, I have it solved for one of the variables. See how it's in slope-intercept form? This is in standard form. But I know what y is, so I can plug that into the other equation. So what we get is 2x plus, where the y is, I'm going to write 3x plus 2. 3x plus 2 equals 10. Now I can combine 5x plus 2 equals 10, subtract 2, get 5x equals 8, get x equals 8/5. Okay, then I still go back up here, and to the expression that I substituted in, I'm going to put my x in. Okay, I'll let you get that copied down because I went through that really quick. Okay, so I'm going to go find y. Y is going to equal 3 times 8 over 5 plus 2. I just put x back in as 8 over 5. So I plug the 8 over 5 in for x. There. Okay. Not a lovely picture. It has fractions, so we have to do that. Okay, so we get y equals 24/5 plus 2. I'm going to make this by 5 over 5. So y is equal to 24/5 plus 10/5. So it equals 34/5. So I now know what y is. So my point is 8/5, 34/5. And again, I can go back and check them both in to see if it's correct. That's something you should do. I'm not going to take the time to do it right now.
Can you leave it up there so I can?
Yes, I will leave that up there for a little bit so you guys can get all that down. I know I went through that fast. You need to be able to follow what I did. If you don't follow what I did on something, please ask me right now.
So just like what we were doing yesterday too.
That was what we did yesterday.
Okay.
Substitution, we did 10, 2 was this part, the y equals, they're both set in this form. 10.3 was this part where you're doing this, okay? Because it was 10.2 and 10.3 yesterday, right?
Yeah.
So today we're doing 10.4 and 10.5. I haven't gotten there yet. I'm just reviewing so far, okay? So this is the easiest if you know that the numbers are going to be really nice. We actually kind of lose that one just because we don't know if the numbers are going to turn out to be integers or not. Okay. So then substitution, its pro is that it can be used for fractional answers because we can find them exactly. This one, it can't be. It's a con of not using fractional answers. This pro is it's easy when you have a variable that's already solved. If one variable is already solved or written in slope-intercept form, okay, it's easy. So if one equation is in slope-intercept form, it is easy to substitute. But that leads to the problem, the con of this method. The con of this method is it's hard to use if no equation is in slope-intercept form, okay? So it's harder when both of them are given to us in standard form or some other form, okay? It's harder, so the problem here is if both equations are in standard form. So that's why they developed another method, because it got to be too confusing. The fractions got to be more confusing, all of that. So they came up with a different method to do it. Now, can you solve all equations by substitution systems? Yes, you can. You can solve every one of them because you can change one into slope-intercept form. Okay, but we're going to show you a different way that you don't have to change them into slope-intercept form. So we're going to talk about when should you use these. Substitution is a lot easier if you have one in slope-intercept form or both of them in slope-intercept form. Okay, it's a lot easier when it's that way. But if you don't, then the next method is the easier way. But both of them work for any equation. Graphing works for every equation. We just might not be able to find the exact numbers. Okay, it doesn't work as well because it doesn't give us the exact numbers. We can get a good approximation from it, but we can't get the exact number. Okay. So we're going to go into, does everybody have all this down now? Okay. We're going to go into what is the new method. I'm going to show you why we want to learn this method. Okay. It is called several different things. I kind of like to put the two things that it's called depending on your math book. And if you go look at worksheets on the internet, they're going to talk about two different methods that are really the same. So this is 10.4. It's called addition in some books method, and it's also called the elimination. Okay. Now again, this is to solve systems. It's to find the point where they intersect. It's to find the value of x and the value of y that makes both equations true. Okay? I like to put it together and say we're going to add to eliminate. You'll understand that as we go through it. So I like to call this add to eliminate method. Because I think that makes more sense if you say it that way. We are adding to eliminate. We're going to eliminate one variable at a time. So let me show you why we need this form. If I have 2x plus 3y equals 15, and I have 5x minus 3y equals 20, okay? Two different equations, right? If I went to graph this, this is the one you guys hate to graph, right?
No.
This is the one where I have to set x as 0 and find y. I have to set y as 0 and find x.
I kind of like it.
Okay, well, some of you like it, some of you don't. It's the one that took you guys the longest to figure out, though.
Yeah,
I
no,
do
that's
know
true.
that. Okay. So, but notice, graphing is not, it's not ideal. We don't know if it's going to come out to be an even number. All right. Now, I don't have one. I could put it into slope-intercept form for one of them, so I could put substitution. So let's try it. Let's do this one. So what I could do, I want to get y equals, right? So I have 2x plus 3y equals 15. I'm going to minus the 2x here because I want y by itself. So I have to minus the 2x here, okay? So then I've got 3y equals 15 minus 2x. Does everybody agree with that? Okay. I need to get y by itself. I'm going to divide by 3, so that means I have to divide each of these by 3. So this gives me y equals 15 divided by 3 is 5 minus 2 divided by 3x. 2/3 x. I now have what y is, correct? I have it in slope-intercept form. And Med's going, oh, I don't like this.
I don't like it.
Okay, and then I could go in and I could substitute it in for that. So now I have this beautiful equation that looks like this. Minus 3 times 5 minus 2/3 x equals 20. Because I'm substituting into this equation. So this was 1. We solved it for y. This was 2. Now I can substitute 1 into 2. Okay. Do you like this process? Oh, okay. Well, good.
No.
Good. We're
I was
compare it
joking.
to the other one.
I was joking.
Okay, so we got 5x. Negative 3 times 5 is negative 15. Negative 3 times negative 2/3 is positive 2x. Does everybody agree with me there? Negative 3. Negative times negative is positive. Let's start there. 3 times 2/3, 3 over 1. The 3's cancel, gives me 2. Equals 20. Okay, 7x minus 15 equals 20. Well, how about this? I've actually got one that works. I got numbers that are actually whole numbers. So that's very unusual. Add 15 on both sides. I get 7x equals 35. So x is going to be 5. Does everybody agree with me there?
I haven't written anything yet. You're going way too fast, so I decided to absorb the information
Okay.
first.
Well, and yeah, you don't have to do. I'm just showing you the steps.
Yeah, I know, but
Okay.
for future reference of trying to do this, I'd like to write down that so I can use
Yeah,
it.
that's fine. I'll leave it up there so you can keep writing. So now I'm going to take this and put it back into my equation 1 in that form. So I'm going to get y equals 5 minus 2/3 times 5. Oh, this is not going to be as pretty.
Wait, what equation are we
I
going
took number 1. Remember, this is
It's like
equation
going
1.
backwards and reverse at the same time.
Yeah. So I'm putting it back into one that I solved for y.
Oh, okay, that one.
Okay, so I'm plugging it back into that one. So this is 1, this is also 1. I put it into that. Believe me, you're never going to have to do this problem this way. I'm showing you a way to do it, but there's an absolute easier way to do it. Okay, so I'm going to show you now. This is minus 10 thirds. So I'm going to make this 15 thirds minus 10 thirds. So y is equal to 5 thirds. So I have x and I have y. I have solved it. That's a lot of work. Do you see a lot of places for mistakes there?
Yes.
Yes. We're going to do the other method, which is called the add to eliminate. Okay, so we have 2x, we're going to do the same problem, plus 3y equals 15. And we have 5x minus 3y equals 20. First thing you need to know, we are going to add these equations together. So we want to line them up. So we want to make sure the x's are lined up. We want to make sure the y's are lined up. We want to make sure the equal signs are lined up. And we want to make sure the numbers are lined up. So you need to write both of them in standard form to do this. Okay.
And if they're not, you want us to mess around with
You
it until it
can
is.
move it until it is, but I wouldn't take one that's in slope intercept and change it. I would just use substitution. Okay, if you have one that's already in slope intercept, substitute, because it's much easier than trying to get it back into this form. Okay, so we're going to start here. So our whole goal is we want to add the equations together. That's the addition part. That's why it's addition. So we have to line up the x variables, the y variables, the equal sign, and the constant. So they need to be lined up. So the x's are on top of each other, the y's are on top of each other, the equal signs are on top of each other, and the constant numbers are on the same. Okay. Our goal here is to eliminate, when we add, we want to eliminate one of the variables. If I look at this equation, these sets of equations right now, if I add them right now, would one set of variables be eliminated?
The y?
The y, why? The y.
Because you're adding and subtracting.
Yeah, you have a positive 3 and a negative 3. So as long as when I'm adding, I have one that's positive, one that's negative, and the same number, they will eliminate. So if I add these eliminate, hence, eliminate.
Or what if they don't?
We're going to talk about that. You need them to be opposites. Numbers in front. We're going to talk about that. That's coming. Good question. Hold it. Okay, so I add these. 5 and 7, or 5 and 2 is 7, equals 35. Divide by 7, x equals 5. Oh, look how many steps that took. Is that better than that mess? Yeah. Okay. I could show you how to do it, elimination and add for the second variable. Also, I'm not going to do that right now, but you can. We'll do one in a minute like that. Yes.
Once you have it at this point, can you just put x in and then solve for y?
Yes, you put x in one of the things and solve for
Doesn't
y.
matter
So
which
it
one.
doesn't matter. So now we are going to take x and put it into either one. I don't care. Either. Okay, so I'm gonna use the first one, 2 times x plus 3 times y equals 15. So I get 10 plus 3y equals 15. 3y equals 5, because I subtracted 10 on both sides. Divide by 3, y equals 5/3. Did I get the same answer as I had over here?
No, well, yes.
Yes, I did. Which one would you rather do?
That one.
Really long
The long
Add
one?
to
Okay,
it,
if
right?
you like to do the long one,
Ask ChatGPT.
you are more than welcome to do the long one. I'm totally fine with you doing it. Okay, so I am totally fine with you doing that. Okay, this is, but hence why I said add to eliminate. We are adding to eliminate one of the variables. That's why I like to call it add to eliminate method, not the addition method, not the elimination method. I like to call it add to eliminate, so that way you really know what you're doing. Yes.
I wasn't paying attention on this right side when I was writing down stuff.
Yes.
Can you describe it again?
Okay, so here what we did, we added these because 3 and -3 will cancel.
Right.
It will eliminate my y.
Yeah.
Okay, so I end up with 2x plus 5x, which is 7x.
Okay.
I end up with 15 times plus 20, which is 35. My equal sign comes down.
Okay.
I divide by 7, I get x is 5.
Okay, that makes sense.
Okay. I now took, and I can put the 5 into either of these equations now. It doesn't matter which. I chose the top one.
Okay.
So what I did was I put 2 times 5, because x is 5, plus 3y is equal to 15. So I use this top equation,
Okay.
putting 5 in for x.
Okay.
That's what I did here.
Okay.
Okay. I multiplied that by itself and got 10.
Okay.
I subtracted 10 from both sides and got 5. So I took 10 away here, take 10 away here, and I get 5.
Okay.
So I get 3y equals 5.
And then you
Divide by 3, and I get y equals 5/3.
Okay.
Okay. Yes,
What if when you add them together it doesn't eliminate?
that's what we're just. Did we just say that? Did I hear an echo?
What did I
What
say?
was your question earlier?
What if?
What if it doesn't?
Yeah. What if the?
They don't eliminate, right?
Would
Oh,
you just do substitution?
we're gonna talk about that. No, 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 no,
way.
no, no.
You're in trouble.
We're not going to. Okay, so let's look at another problem. I'm not gonna do it both ways this time. We are just gonna do
I
add
think we
to
should do
eliminate.
both, because we need an example. You need to do the long one too.
No.
You're so good.
Running out of paper.
And get more. I put a whole bunch more up there yesterday. Actually, Brielle did that for me. She put it all up there for me, so we had more paper up there. Okay? Okay, so I'm gonna give you another problem. This is 3x minus 4y equals 22. And you guys know me, I'm just making these up off the top of my head, so fractions are very possible. Okay? So, and then I'm going to use 6x plus 1y equals 11. I have no idea why, but we'll see. There's our set of equations. Okay? Do they, right now, if I add them, do I eliminate one of the variables?
No.
No. Okay, because right now, if I add them, y's don't go bye-bye and x's don't go bye-bye. It doesn't matter. So, which one do you want to eliminate? You guys tell me.
The 6. Yeah, what's that?
The 6? Okay.
No, the Y.
I don't care which one.
Eliminate
Which
the
one?
Y.
Let's
Why?
take
The
away
Y is gonna be
the 22 and 11.
Yeah.
That's a good idea.
No, you can't do that. We need to eliminate a variable.
Eliminate
Equal
Y.
sign.
Let's take a
Y.
vote, let's take a vote.
X.
How many people would like to eliminate the x?
Grayson, you betrayed me.
How many people would like to eliminate the y? Okay,
You betrayed
So-
me.
to eliminate the y, what do we have to do?
We subtract.
No, I'm asking a question. What do I have to get this to be right here so it eliminates?
-4.
Do I need a negative 4?
What?
Or
Oh, no, positive.
I need a
yeah.
positive 4 because right now I have a negative 4. So if I could make this into a positive 4, we could eliminate, right?
Yeah, so you add 4 to.
Nope, we don't add 4.
we multiply everything by
We
4.
multiply everything by 4 because if you take any equation, I'm going to just show you this. If you take
Oh.
6 plus 1 equals 7, if I multiply that by 4, 24 plus 4 equals 28. Do I still get a true statement?
Yes.
It's just multiplied by 4 all the way through. Okay, so I can multiply an entire equation by a number. So that's what you do. So let's see what we get now.
Just the bottom, you don't do the top and bottom?
Well, let's see. Do we need to do the top? If I multiply this by 4, it'd be negative 16. Now would they
you have to
cancel?
multiply the bottom
Yeah, by 4 more.
Yeah,
And then we can just keep going and we just be doing this for all day. Okay, we want to get this to be positive 4 so the negative 4 cancels. So I only have to multiply this one. So we're going to get 3x minus 4y. I rewrite it down. So what I do is I rewrite the first one, then I multiply, I get 24x plus 4y equals 44. So I just multiplied this by each thing. Okay. So we had to first multiply to get it so that when I add them, it eliminates. Remember, we're adding to eliminate. When I add, it doesn't eliminate anything, you don't want to add because it doesn't help you. Okay, so now I can add, I've got these canceling, those eliminate because one's positive, one's negative. I add, I get 27x equals, oh, an awful number, 66. Okay, so divide by x by 27, so I get 66 divided by 27. I do know 3 goes into both of those, correct? Does
Yeah.
3 go into 66?
Yeah.
Does 3 go into 27?
No.
Okay, well,
Yes, it does.
okay. 22 ninths. Okay, so x is 22 ninths. I didn't say this was going to take away. Okay, now, some of you don't like fractions very well, right?
Thought it was just you.
Well, you guys can like fractions if you want. They are your friends. But
What are they?
we could go back, we could put this in for one of these, and we could solve. I'm going to show you the other way you can do it. Okay. Here we eliminated.
We eliminated the y. We can
Y.
eliminate the x.
So we can now eliminate.
I can already see this way it looks like it takes longer.
Well, we'll just see.
See it takes.
I don't care which way you do it. I'm showing you some options. Okay. To eliminate my x, let's go back to our original equations. What would I have to do to get these to be opposite of each other? What would I multiply by? Yes.
-2.
A -2 on the top, right? If I multiplied the top by a -2, it would cancel with my 6. Okay, so I'm going to rewrite this as -2 times 3x minus 4y equals 22. And I'm going to have 6x plus 1y equals 11. Because I don't want to get confused with what I'm doing there. Okay, so you can rewrite the problem and then indicate what you're going to do. So I'm eliminating x now because now I'll get -6x plus 8y, right? Negative, that's -6. Negative times negative is positive. Negative times negative is -44. Okay. Now I can add, my x's eliminate. I get 9y equals -33. Does that, everybody agree with me there? 9y equals -33 because 11 and -44 is -33. I divide by 9. So y equals -33 ninths, which I can reduce by 3, -11 thirds. So y equals negative 11 thirds. Some people find that easier. They don't have to work with the fractions as much. Okay, so you can eliminate the x and then the y, or you can eliminate the y and then the x. It works. Okay, so that makes it work both ways. Makes sense to you. Okay, so that's to eliminate. Now, I'm going to give you another one just to make it a little more challenging. Okay. Our third example.
You're on your third. Yeah. Like this is one piece.
One
Or
piece?
One
Just-
piece,
just one
two
side.
piece.
Okay, here's my set. I will tell you, when you're doing this, the more organized you are, the less mistakes you will make. Okay? So a lot of times how I do it is I write my original equations and just keep them right here together. Okay? And so let's say I'm doing 2x minus 5y equals 11. And that wasn't a very good one. Oh, yeah, we'll do 5x plus 2. No, we're not going to do that. Oh, yeah, we could. That works. Plus 2y equals 7. I have no idea what these are going to equal. Okay?
5x plus 2y.
Sorry, I was putting my throat.
Yep, can you say that?
No. There's no way we've only been class 45 minutes.
7. We don't add up.
Ooh.
7-11.
I found it.
I want a Slurpee now.
Do you want us to solve this? Solve.
Yes, by ourselves.
Okay.
Okay,
No,
now
no,
I'm
no,
just
no,
going to
no.
kind of go over this. So then I break them across. I want to eliminate y, and I'm going to eliminate x. So I break it into two pieces, basically, my piece of paper, because like I'm saying, the more you keep yourself organized, the better. So to eliminate y, I would have to multiply the top equation by what?
2.
2. So we're going to multiply top equation by 2. What are we going to multiply the bottom equation by? Multiply the bottom equation by 5. And if you want to write those down here, you can. If you want to say 2 times 2x minus 5y equals 11 and 5 times 5x, that wasn't right. Oh, we're eliminating y. Yes, it is. Plus 2y equals 7. Okay? Write them down. Okay? Now, do my multiplication. So I get 2 times 2 is 4x. 2 times negative 5 is negative 10y. 2 times 11 is 22. Okay? I like to draw a line between them so I can see. 5 times this is 25x. 5 times this is positive 10y. Oh, good, they eliminate. Equals 5 times 7 is 35. Now I can add. I get these eliminated, so I get 29x equals 57. X is equal to 57 29ths. That does not reduce. So that is one that you don't want to have to work with, right? Because it's all weird. Okay. So we found out what x is. Not too bad, really, right? What would I have to multiply my top by to eliminate the x's?
-5.
Okay, we could do it by negative 5. So multiply top by negative 5. Because we want to make this negative, and then we're going to make this one positive. So what would we multiply the bottom by?
Just 2.
By 2, okay? Because we want it there. So we're going to have negative 5 times 2x minus 5y equals 11. And 2 times 5x plus 2y equals 7. Okay? Negative 5 times 2 is negative 10x. Negative 5 times negative 5 is positive 25y. Negative 5 times 11, negative 11 equals negative 55. I couldn't talk. 2 times 5 is 10. 2 times 2 is 4. 2 times 7 is 14. My x's go bye-bye. Now I get 29y equals negative 31, is that right? No, negative 41. Negative 41 divided by 29. Y equals negative 41/29. There's my x, there's my y. Would you have wanted to put this back into one of these and solve it?
No.
Definitely not.
Probably not. That's why I like to show people that it works to eliminate x and to eliminate y, and you get both answers.
I'm gonna put this on Desmos to find the answer. I'm not gonna put it on the graph itself.
If you put it on Desmos when I asked you to do the work, you're not gonna learn this method.
No, not the
You
equation
can
itself.
check it.
Yeah.
So
but
I would recommend, because to check this, that means you put these both in and see if they work. To check them, I would recommend you could put them in Desmos and you can see where they intersect. You can find their point of intersection and it should work out to
I'm
be
saying
those.
if you want us to graph that, I'm saying I'm gonna put that on Desmos.
Oh, yes, if you want to graph those, yes. Because you would never find that on your own lines, let me tell you. You would never know that it's 57/29, which is, let's see, 48, almost, it would be 1 and 28/29, almost 2. Okay, the other one would be 1 and negative 1 and 12/29. Okay, so that's the two different ways to work on that problem, okay? I will let you have time to finish writing that down. I wanna make sure everybody gets that written down.
I did.
But the thing is to know is that you can multiply both equations by a number. And you guys were quick to see what numbers to multiply by. Okay, it's kind of like getting a common denominator. You're multiplying by those numbers, like getting a common denominator. You just wanna make them the same, but one has to be negative. Otherwise, it won't eliminate when I add. Okay. So that is all of what that one is about. I think it's time for you guys to take a break because that was a lot. So go take your break now and then you can come back and we'll work on problems.